Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 172, and today is our lesson number 157. Problem number 142 is what we're going to do on page 172. Problem number 142, the very last problem in the first column. Here's what we are told. We are told that we have driven 290 miles. We have driven 290 miles. We drove 290 miles, and as a result we burned 12 gallons of gasoline. This amount is rounded to nearest 10, and this amount is rounded to nearest gallon. The question simply is, let's see, how do they phrase the question? The actual number of miles per gallon that the person got on the trip must have been between what and what. So they're looking for the best case scenario and the worst case scenario. That's what it is. So the actual mileage is going to be somewhere between the worst case scenario and the best case scenario. The best case scenario is where you burn the least amount of gasoline and drive the most number of miles. The least amount of gasoline that we can buy, given the fact that we are rounding it to 12 gallons, the least amount that we can buy, that we can burn is 11.5. Maybe she burned 11.5 gallon, which was rounded to 12 gallon. And the highest number of mileage that she could have gotten, because of the fact that it is 290, is perhaps 295. Maybe she went 295 miles, which was rounded down to 290. That's the best case scenario. Here we're getting the highest number of miles for the least number of gallons. The worst case scenario is that we actually burned 2.5 gallons, which was rounded to 12 gallons, and in reality we did not get 290 miles. Perhaps we got only 285 miles. And that's it, we're done. That's your answer. 285 divided by 12.5 and 295 divided by 11.5. That's the range. And that will be what letter? 285 divided by 12.5 and 295 divided by 11.5, that's letter D. That's it, we're done. That's our answer. D is the answer. Let's move on to the next question, shall we? Let's do the next problem. Let's see what they ask us in the next one. But there is nothing we can do here. There is no solution that I can present to you, because there is nothing here to solve. In problem number 143, they give us a number line. And the question simply is, which is the proper algebraic expression for the shaded portion of the number line. So here is our number line that they give us. here's the 0, 1, 2, 3, 4, 5, here's the negative 5, and then negative 6, 7, it goes on forever and ever. Here's the negative 5, and it goes all the way up to 1, 2, 3, to positive 3. If you look at the book there, make sure you have the book in front of you, page number 172. If you look at it, it's between this and this. This is the part that we're looking for. Between negative 5 and a positive 3. Let's see what they give us. So here, as you can see, x is between negative 5 and x is between negative 5 and positive 3. And how do we write it? This is how we write it. X is between, which means it has to be greater than or equal to negative 5 and less than or equal to positive 3. This is what we're looking for. We're looking for something that gives us this. Let's look at the answer choices. Answer choice A says absolute value of x is less than or equal to 3. Right away we should realize that that is not the right answer. Why is that the right answer? Why is that not the right answer? Because it makes no mention of 5. Either positive or negative. 5 doesn't appear in it. We need a 5 and a 3 in our answer choice. That's not it. What does this actually say? This says, for example, if x happens to be negative 4, then the absolute value of x is going to be positive 4, and we are told that, well, that was not going to work. X happens to be negative 4, absolute value is positive. X cannot be negative 4. You see, x cannot be negative 4. What this tells us is that x has to remain between negative 3 and positive 3. If you were to show it right here, 1, 2, 3, negative 3, 1, 2, 3, positive 3. X is somewhere here, between negative 3 and positive 3. Because as we just saw, x cannot equal to negative 4 because x cannot equal to negative 4 because had x been negative 4, had x been negative 4, the absolute value of x would have been positive 4, and positive 4 is not less than or equal to negative 3. Positive 4 is greater than positive 3. So that doesn't work. It's between negative 3 and negative 3 and positive 3. That's not what we're looking for. We're looking for something negative 5 and a positive 3. A is not the answer. In B, they tell us that absolute value of x is less than or equal to 5, which means x is between negative 5 and positive 5. X is between negative 5 and positive 5. This is separate. Right here, between 0, there's a negative 5, there's a positive 5, x falls somewhere here. Now this portion is fine. Between negative 5 and 0 is fine, but it cannot go beyond 3. This one is going all the way up to positive 5. It cannot go all the way up to positive 5 because this one stops at positive 3. That's not right. Let's look at C. Answer choice C. In C, they tell us that the absolute value of x minus 2 is less than or equal to 3. This tells us that x minus 2 is between negative 3 and positive 3. That's what this tells us. And how do we write it? Like this. It's between negative 3, which means it has to be greater than negative 3, greater than or equal to negative 3, and less than or equal to positive 3. That's what this tells us. X minus 1, whatever this quantity is, has to fall between negative 3 and positive 3. That's what absolute value means. Let's solve for x. Let's add 2 to the entire inequality. We're going to add positive 2 to the entire inequality because we want to get rid of this negative. So we have a negative 2 here, a positive 2 that drops out, and we are left with x in the middle, which was the whole bloody point because we want x by itself. So here we have a negative 3 and a positive 2. A negative 3 and a positive 2 is a negative 1. A positive 3 and a positive 2 is a positive 5. This is not what we're looking for. This one goes from negative 1 to a positive 5. This one goes from negative 5 to a positive 3. It's not the same thing. We're not going to waste our time plotting it on the number line. This is not it. Let's look at D. Let's look at D. D says x minus 1, absolute value of x minus 1 is less than or equal to 4. This tells us that this quantity x minus 1 is between negative 4 and a positive 4. This quantity x minus 1 is between negative 4 and a positive 4. This is how we write it. Negative 4, x minus 1 has to be more than negative 4, but less than positive 4. Less than or equal to positive 4. Let's add 1 to all the sides here, the entire inequality, so that we can get rid of this one. Negative 1 and positive 1 drops out, and here we have negative 4 and a positive 1. A negative 4 and a positive 1 is going to give us negative 3. Right away we know it's the wrong answer because we started negative 5. This is not the right answer. And here it's just the reverse. We need a negative 5 here and a positive 3 here. That's just the opposite. That's not it. The answer is E. We're going to show it. That's not it. E obviously would have to be the answer. It's the only one left. X plus 1. The absolute value of x plus 1 is less than or equal to 4, which means this quantity x plus 1 is between negative 4 and a positive 4. X plus 1 is greater than or equal to negative 4, but less than or equal to positive 4. Let's add and let's subtract 1 from everywhere. This positive 1 and negative 1 drops out, and here we are left with x. Negative 4 and negative 1 is going to give us negative 5, which is exactly what we have here. And positive 4 and negative 3 is going to give us positive 3 here, which is exactly what we have here. Voila, this is our answer. The answer is E. Alright? I'll see you tomorrow, okay? Bye now.